Hey everyone, welcome back to another episode on Space Door Live. We're back with another amazing show with Nick and Terry. It's the Space Roundup for you, which we have changed to a monthly show. So hopefully you're tuning in after a month. Hey Robert, nice of you to join us, and welcome to everyone else who's joining us on this lovely Tuesday evening. How are you doing, Nick and Terry?
Pretty good.
Good to be back.
Good to be back too. Awesome. Well, strap in for another great show, and I will see you guys on the other side. Hope you guys
fine.
Well, we're all buoyant because obviously we won the Euros, we won the European Championships, the football. So everyone in the UK is currently in a really happy, buoyant mood. How are you feeling over in Northern Ireland, Terry?
Oh yeah, we supported them, of course, too.
I know. No, it's fabulous. It was
really,
really
the
really
women
good.
to bring football home after the
it
men
was tried. It just goes to show you, when you invest in something, and we can talk about this in the space sector quite considerably. If you invest in something properly, it gets fantastic results. But anyway, moving on from the glorious news of the football. We've got some biggies this month. We've moved to a monthly slot post-COVID. Everyone's out of lockdown now. Most people are fed up of staring at Zoom screens, etc. every 2 days or whatever. So we thought we'd move to monthly. Plus, it gives us more time to kind of collect some really, really fun and interesting stories. The big one at the moment, obviously, is the arrival and complete deployment and pretty much perfect science operational start of the James Webb Space Telescope. We touched on this many times. We touched on it before it was launched. Everyone keeping their fingers crossed, etc. Absolutely fantastic to see this happening. So the James Webb is now operational and delivering some amazing images, and Terry's going to tell us all about it.
Yeah, well, I can't tell you all about it because there's just far too much.
There's far too much.
But it is literally absolutely groundbreaking, mind-blowing, stunning stuff, and full of the most amazing science. And don't turn off before I finish because there's breaking news coming just at the very end. Now, as I say, it's breaking news. I've had to amend my notes, so I'm going to have to refer to them a couple of times because it literally is hot off the press. If anybody doesn't know about the James Webb Space Telescope, they must have been literally on another planet. So I'm assuming you know about it. If not, you can put it in the questions. One of the things that it is tasked with doing is finding out about the very early universe, how the very first galaxies formed. And it is brilliant at doing that. That is one of the things that it was specifically designed to do. And it's taking advantage of our good friend Albert Einstein and an effect called gravitational lensing. Now, even the JWST can't see the very first galaxies that formed just after the Big Bang without help. And what they do is they've picked a very large galaxy cluster called Abell 2744. It is so massive that the mass in that galaxy cluster bends the light from more distant objects beyond it as a gravitational lens. They study the vicinity of that galaxy and they look for the images of galaxies that are beyond it. And it has already found stuff that, again, is just mind-blowing. Only within the last week, it set the record for 2 new galaxies, which were further and therefore older or earlier in the life of the universe than the previous record. And they're called GLASS Z11 and 13. I'll explain that. GLASS stands for Grissom Lens Amplified Survey from Space. So what they do is they use this survey to look for very, very old galaxies in the vicinity of the Abell supercluster so that they can detect them with gravitational lensing. And within an area that they've searched so far, which is only about the size of the full moon in the sky, so it's only a tiny area of space, they've found 2 new ones which both broke the previous record. As I say, they're called GLASS Z11 and GLASS Z13. And the 11 and the 13 stand for the redshifts. In other words, because of the expansion of the universe, the light from those galaxies has been shifted by a factor of 11 and factor of 13 beyond the normal, sort of the laboratory spectrum. And when you convert that to distance and age, in terms of age, what we're interested in, that's 13.4 and 13.5 billion. You're seeing those galaxies, they were 13.4 and 13.5 billion years ago. Now, we were talking about this before we came on air. Given that the current estimated age of the universe is 13.8 billion years old, that means we're seeing those galaxies as they were just 300 million and 400 million years after the Big Bang. And how, even though they're smaller than our own Milky Way galaxy, they were still bright enough and massive enough to show up, even using gravitational lensing. How do galaxies form?
They don't, Terry.
Yeah, I mean, our Milky Way, we believe, is probably about 10 billion years old, and our own sun and solar system is about 4.5 billion years old. So going back even beyond that, it's hard to imagine how a galaxy can form that quickly after the Big Bang, when everything was expanding out at an absolutely incredible rate. Now, first of all, a word of caution. Those figures are taken just from the color of the light. They await to be confirmed by an actual spectroscopic analysis by the near spec instrument, the near infrared spectral instrument. So far, people are reasonably sure that those figures are accurate, but they are subject to confirmation. Now, this gives us, without coming on to the breaking news, 3 amazing, fascinating puzzles. First of all, how have they discovered 2 already in such a tiny little area of space? Secondly, how, as I've mentioned, have they already formed to the point where they're bright enough to be seen after such a short time? And how did they form so quickly after the Big Bang? Right, that was the news up until shortly before we come on air. The record has been broken again. This is a different survey. They weren't even looking for the most distant galaxies. This is a survey called SEERS, the Cosmic Evolution Early Release Science Survey. And basically, they were looking at early old galaxies, but they wanted to see how they evolved over time. They weren't looking for a new record breaker, but they think they found one. And it's called SEERS, the acronym of that survey, SEERS 93316. Again, it's subject to spectroscopic confirmation, and it hasn't been peer-reviewed. It's been published in arXiv, but so far JWST has sort of what it has delivered is what is actually there. It has a redshift of, wait for it, 16.7. It shatters the previous record. That means that galaxy, if that figure is correct, formed only 235 million years after the Big Bang. I mean, that's going back basically to the sort of the start of the dinosaur period on Earth. So that's within a time frame that we can comprehend. Just about, we know the figures for the age of the dinosaurs. They end at 65 million years. They first appeared on Earth about 270 million years ago. So we can just about conceive of a figure of 235 million years. But for a galaxy to form, to be bright enough to be seen with gravitational lensing, 235 million years after the Big Bang has them scratching their heads.
Yep.
Now, there's two possibilities, according to me, and I am not a cosmologist or an astrophysicist. Either the universe is a bit older than the currently accepted figure of 13.8 billion years, which will cause massive headaches in all sorts of directions, or there's something that we simply don't know about, possibly extremely dense clumps of dark matter, although how you would get those dark clumps in the Big Bang. They acted as sort of gravitational wells for the galaxies with normal matter, which formed into stars to form. Now, that's within the first couple of months or so of sort of science operations of the James Webb. What's going to come next? We don't know. It is already just mind-blowing stuff. And we had a brief chat about this before we come on air. I know you don't like the dark matter idea, so what do you think this is all about?
Oh God! Right. So when I studied astrophysics, we had a guest lecture from a chap that you probably know very well, Terry, called Fred Hoyle.
Yeah,
and
personally.
obviously, yeah. But the whole concept of the steady state theory, and yes, obviously the mathematical and scientific evidence all points towards the fact that there was a Big Bang. But as you said, if the Big Bang did happen at 13.81 billion years ago, there's no way. You cannot form a galaxy in 235 million years. You can barely form a moon in that kind of time scale. I mean, you're looking at, the collision that formed our own moon. It's hundreds of millions of years for planets to form, hundreds of millions of years. Some of the pre-solar grains that they're finding in meteorites, evidential of the shockwave that created our solar system, are going back, 7-8 billion years. So it doesn't compute at all. It does not stack up at all. It's like we're going back to the 1500s again, where we couldn't understand why the Earth wasn't the center of the universe, and they were putting in all sorts of ideas for why Mars's position in the sky was changing and all sorts of hokum. I think that's exactly what's happening now, but in obviously a much more advanced way, in that we're throwing all sorts of we're going to do dark matter, we're going to do dark energy, we're going to throw superstring theory. The simplest answer, Occam's razor, is normally the one that works, and there's got to be something. There's got to be something really simple that humanity, the greatest minds, some of the greatest minds all through history have got things wrong. I was watching a documentary about the discovery of King Richard III in Leicester car park, and the lady who originally said he's there, she was literally stood on an area in a car park with an R written on it, and it was R for reserves. And she said, he's here. And all the academics and scientists at Leicester University laughed and said, oh, this is ridiculous. He was. So academics can get it wrong. I'm not saying that they have got it wrong. I'm not saying that the Big Bang Theory is incorrect, but there is something just not right with these numbers, and it's absolutely fascinating. Then we come on to all the other discoveries that potentially are going to come flooding out of this. When we come to planetary atmospheres, we look at the hot Jupiter issue, and we look at have we got planets orbiting like ludicrously close to stars, with gaseous atmospheres that they're finding water vapor in. All of it just, there's something wrong. There's something I think we're missing. Galactic rotation, they threw in dark matter, dark energy to explain the anomalies in our own galaxy's rotation rates, etc. So there's more to come from this. That's all we can say. the numbers you've just given, I didn't even know that. You just, as you said, broken that on air. It's fantastic. It doesn't add up. You cannot form, all the theories of galactic formation point to that being impossible. So what's happening? You can talk about gravitational wells. You can talk about, it doesn't add up.
And if the universe is older than 13.8 billion years, that sort of cuts the rug out from under Kobe and Planck. That amazing curve of the black body radiation. It seemed so perfect that it had to be right, but something doesn't fit.
So Robert's
that's
asking,
what James Webb was designed to do.
Absolutely. And Robert's brought up a good question in the chat. He said, why haven't we seen older material before? Yeah, it's literally sheer distance and the fact that it's redshifted. Hubble was optimized around the optical and the very near infrared ends of the spectrum. James Webb, obviously, vastly bigger mirror. So much greater light grasp and light, gathering capability, but it's also the instrumentation, the MIRI, NIR spec, etc., are all optimized into the far mid-infrared regions. So technically, they can see further out of the box. Once the square kilometer array radio telescope comes online, again, all bets are off with this because the SKA. I worked at the SKA for 2 years. They were talking about the cosmic dawn and, however many hundreds of millions of years before the first stars formed. We're now saying that, forget that, galaxies were forming half that time. It just, again, and these are the greatest minds on the planet who were working on things like square kilometer array. Don't forget, this is the most complex instrumentation ever built on the surface of the Earth in terms of computing power, etc. These people aren't stupid. So somebody's got something very, very, very fundamentally wrong here. And it's fascinating. It's absolutely blowing my mind every day. It's like the Hubble. We waited obviously years for the Hubble to get the co-star optical correction and then the first images, and then we saw the stunning images. And one of the things I will say for the James Webb team, unlike Herschel, and Herschel delivered great science. Don't get me wrong. The Herschel Space Telescope from the European Space Agency. PI was at Cardiff University. Matt Griffin, great team, great bunch of people, but the images sucked. I mean, the mirror, obviously, you're into the infrared end of the spectrum, so you're looking at longer wavelengths. The mirror diameter is critical. If you've only got a mirror roughly about the same size as the Hubble, which is what they had on Herschel, then your images aren't going to be as clear as the Hubble. But essentially, the processing, obviously, the scientific output from the processing was fantastic, but the quality of the images coming out the James Webb, whoever's doing the image processing for the public is hitting the nail smack on the head. You only have to look at the image you've got on screen now. It's beautiful. It's beautifully done, but also, as you've said, Terry, and we're going to be seeing more and more of this. Probably every show we're going to be featuring a new James Webb discovery. But that's the thing. It is already it's hit the ground running, and all we can, fingers crossed, and hope for is that we don't get any more micrometeorite impacts, because obviously it's been hit already by something no bigger than probably a grain of salt. But at 8 kilometers a second, that's a nasty impact. That's like hitting, your average glass mirror of a lump hammer. And these are, beryllium, gold-coated beryllium kind of plates, as it were. We don't want anything to go wrong with James Webb now, because the science output is so astonishing already. There's been so many hours devoted to this across multiple news channels already. So definitely watch this space. It's astonishing. It really is. I can't say any more than that. It's just, it's blowing my mind. It is absolutely blowing my mind.
And that was the near infrared camera. And there's also the MIRI, the mid infrared instrument as well, which will see anything if there is anything visible with an even longer wavelength, a greater redshift. But what we have already is, again, just mind blowing.
And MIRI was designed here. British invention,
absolutely.
University, led by the University of Edinburgh. Fantastic team up there. Right, let's move on to something a lot closer to home. Buzz Aldrin. So, as some of you may know, I've done a lot of work with the Apollo astronauts over the years. Got to spend a lot of time with Buzz a few years back, actually, about 10 years ago now, at Space Fest. Got talking to him for over an hour. We were talking about Sierra Nevada, everything he was doing. And his assistant, Christina Korp, really nice lady, kind of a bit tense, as it were, at first, because obviously a lot of people just want an autograph on Buzz and they're trying to blag everything. But Buzz has been a real icon. It's one of the few examples, I'd say, in history where the person who came second is as famous as the person who came first. Neil Armstrong obviously sadly passed away about 10 years ago now, and Buzz Aldrin, second Edwin Aldrin as he was known then, second human being on the surface of the moon. Mike Collins obviously up in orbit on Apollo 11. So Buzz has been known to be probably one of the more temperamental of the Apollo astronauts. A lot of them, Charlie Duke, Dave Scott, they're all great people. A lot of them are very modest, very kind of, pardon the pun, down to earth, really, really nice guys. Buzz is a bit more touchy, but again, it's carrying huge weight on your shoulders here, and he's publicized quite happily throughout the years his mental health issues and alcohol issues and all sorts of things. But he's also throughout the years steadily kind of drip fed bits of his memorabilia, partly to pay off alimony, from what I was told at one stage, because he's got several ex-wives. Partly because at one point his kids were suing him as well. It's really, really messy in some respects. It's a shame because he is an icon. But a few weeks ago, Buzz basically put about 69, I think it was exactly 69, of his personal effect items from the Apollo 11 mission and from his Gemini missions and other missions up for auction at Sotheby's in New York. And everybody expected this to be big. And obviously a few years ago, we had the famous Armstrong auction where Rick and Mark Armstrong, Neil's two sons, basically got a lot of their father's stuff, put that through auction. We had pieces of the Wright Flyer, for example, that had gone to the lunar surface with Neil. All sorts of different items, and that raised an awful lot of money. This has broken all records, though. Buzz Aldrin's flight jacket alone has pretty much, as we say in the headline, that has broken a lot of records. So the total for this auction at Sotheby's was around about $8 million, which for 69 items is some going. The jacket itself raised about $2.8 million. So $2.77 million, I think, is what it actually went for, plus obviously whatever commissions. Now, this is the beta cloth jacket that they wore as kind of a coverall on the way to the moon. And there's a really famous photograph of Buzz wearing this basically inside the lunar module. You've got the really famous mission patch. And, as somebody who does, I actually collect Apollo memorabilia myself. I have done for many, many years. In the last few years, it's gone crazy. I mean, most average people now, it's unaffordable. You can't get this stuff anymore. I mean, I've got flight plan checklists from Apollo 12. I've got mission patches, return before flight tags, bits of mission control, all sorts of things. But a lot of that's been kind of given to me and donated by various people that I've met over the years, as part of public outreach, and, things that we do, like this show, for example. But this, I mean, Buzz really set the record books flying with this one. 68 out of the 69 items sold, and bizarrely, the one that everybody thought was going to sell didn't, and that was the pen. So if you don't know the story, on the lunar surface, there was a problem with one of the circuit breakers, which basically was going to be the ascent engine firing to get them off the lunar surface. And the circuit breaker switch broke. So Buzz, being Buzz, improvised with basically a felt tip pen, jamming it into the circuit breaker socket, and they got off the surface of the moon. That pen and the broken switch were put up for auction, and they were estimated to go anywhere between $1 and $2 million. It actually only got up to $650,000. Which is still astonishing for basically a Sharpie. It's not much more than a pen and a kind of bit of bolt, but it is crazy just how much this stuff is going for. And it does beg the question, should it not be donated to a museum? And I know we talked about this before we went on air. A lot of the collection that I've got, yes, it is a private collection, but I do donate items for public display because I want to share as much of that with the public, hopefully get kids inspired, people that go to see it. And I've had loans to National Space Centre, British Museum, etc. And I know a lot of the big collectors do this as well. You got people like Steve Jurvetson, for example, who used to be at SpaceX. He's got an enormous collection of all sorts of stuff. Jimmy Wayne Luke is a good friend of mine. He had one of the only Apollo guidance computers in the world. That went up for auction a while back. As far as I'm aware, that actually did go to a museum. So it does beg the question as to whether or not, Buzz is 92. He's obviously aware that his time on this earth is probably quite short now. He is getting on. He probably wants to enjoy the last few years of his life in the kind of luxury that he's been used to, and he's been treated as he should be, rightly, as an incredible national icon, not only for America but for the whole world, doing what he did. Nobody's ever going to do that again. Nobody's ever going to be like part of the first crew to land on the moon ever again. When Artemis SLS lands, in 2026 to 2028, whenever, yes, we're going to see hopefully the first woman on the surface of the moon, first person of color on the surface of the moon, but you'll never forget Apollo. It was the greatest technical achievement in human history. So, my hat tips to him for that. But it's whether or not, I don't know what you think, Terry, whether or not these items should belong in a museum. Something of this level of importance, the pen, for example, the story behind that is so important. Should it be in a museum? I don't know.
Yeah, I have a lot of sympathy with that view. You probably don't want everything that's connected with Apollo 11 in one or more museums, but you want the critical stuff. Now, I don't know whether the actual flight suit and helmet that they wore on the surface of the moon are in museums. I'm presuming
they're at the
Yeah.
they're in the Smithsonian collection. Yeah,
Yeah,
so they
I
were
thought
restored.
so.
Yeah.
Yeah. So the really important, iconic stuff needs to be in museums. Whether he wants to sell his underwear that he wore on the moon, I don't know. That's up to him. So I've mixed feelings. The guy needs the money because they got paid very little as an actual astronaut. I mean, they get paid buttons. They got paid the same as anybody else of the same rank, basically, although Neil was a civilian. But if you were, say, a lieutenant in one of the American forces, just because you've been to the moon didn't mean you got any extra salary. So, good point in terms of, he's entitled. He bloody well earned it, in my opinion.
The thing is, though, I mean, you say about it's like Elvis. Elvis has made more money since he's been dead than he did when he was alive. And Buzz, I've been at so many conferences with Buzz where the line of people waiting for his autograph has been literally 100 meters long. And Buzz charges $500 to sign anything, no matter what it is. If you want a baseball signed, it's $1,000. If you want what's called a completion signature, where Neil and or Mike has already signed an item, you're looking at $1,000. So, I've seen the returns. We used to help out at a conference in America called Space Fest, and Buzz would make $70,000 in the matter of like a day or two. Just from writing his name on a piece of paper. So he's not short of a few quid. Let's put it that way.
But putting up the price like that has another effect, and that is to deter the numbers. Because if he was selling them at $10 each, the queue would be round, not just the block, it'd be round the whole city of New York or wherever it is. You'd have tens of thousands of people queuing up for that sort of thing. So if you put the price up high, it deters everybody except the real enthusiasts. And I think you have to be realistic to do that.
It's crazy though, again, I've got pretty much all, not pretty much every single Apollo astronaut signature, but it's also the disparity between it, because sometimes, people like Fred Hayes, for example, Apollo 13 didn't land on the lunar surface, but equally as famous, him and Jim Lovell, obviously, and Jack Schwager. Apollo 13 was an iconic mission. Now, Fredo will sign stuff for about $100. He works at one of the, he runs and helps work at one of the museums over in like his home state. And it's really interesting. Charlie Duke was the same. Charlie Duke was over in the UK a few years ago in Milton Keynes and was signing stuff for like 50, 60 quid at a time, which is fantastic. And then you look at some of the Sotheby's auctions, and a Charlie Duke signed panoramic picture sold for $30,000. And it's just, it is crazy. It's absolutely crazy just how elevated the prices can be if there's a perceived, I don't know if it's a perceived value. I don't know, but I find it in some respects in regards a bit obscene when it gets to those kind of levels. I mean, there are certain things that are truly iconic. Some of the Omega watches, the Speedmaster watches, one of the Apollo 17 watches came up, a few years ago. Ron's watch came up, and you can imagine things like that are going to go. An Omega watch is $10,000-$12,000 before it's flown to the moon, so you can understand that. But some of the items that are coming up, I don't know, like the Apollo 11 auction with the Wright Flyer pieces. We're looking at a piece of cloth, literally 2 centimeters square. Some of them were selling for $100,000 a go. So. Yeah, it's interesting. But if you want to see the full auction details, if you just Google it and go on Sotheby's site and you have to log in and sign up, you can see the value of some of the items, even the Gemini checklists. I mean, we're talking about low Earth orbit missions here, obviously precursor to Apollo, they were selling for $20,000, $30,000, $40,000, just for a checklist. And sometimes even a single page from a checklist can fetch $5,000 to $10,000. So it's interesting. The main checklist, the other one, the big seller at the auction, was the flight plan, the Apollo 11 flight plan, which obviously was the entire flight procedures plan. That sold, I believe, for about $800,000 to $900,000, about $850,000, I think it sold for, including the commission. It is, yeah, as Robert said in the chat. Wow, yeah, it's astonishing. Not much more we can say about that. But
I think you need to go on to something more topical.
Yeah, it's like when most of the country's struggling with cost of living crisis, and fuel prices are going up and what have you, to see the kind of expenditure, and it's an anonymous bidder over the phone that bought the jacket for just under $3 million. So I hope they enjoy it. That's all I'm going to say. Anyway, moving on. Next story.
Right. Sorry, I thought you were going to talk a bit about the Roscosmos and the ISS and so on.
Well, actually, I could lead on to that because this kind of links in. So,
right, okay,
it's up to you, Terry. I mean, I'm quite happy.
Right.
But essentially, as you know, Roscosmos have been playing silly sausages, haven't they?
Right. Okay. I'll go on to this, and you can add a bit on at the end.
Cool.
Yeah. Right. Okay. It just shows this is seat of the pants stuff whenever we're putting this together, because everything is so topical. Yeah, a big chunk of Chinese rocket material. If you're watching the news, everybody was a bit concerned. It was about 20 tons, and it was due to splash down somewhere on the Earth, or perhaps bang down somewhere on the Earth, and nobody knew where until the very, very last moment. And it has come down. It seems that it started to enter the Earth's atmosphere and first become visible over the Indian Ocean. It was then tracked, and people actually videoed it going across Malaysia. But while we don't know where all the stuff landed, the Chinese have said that the biggest part actually landed in the sea off the western Philippines. And nobody's recovered it yet. I don't know if anybody's actually going to try. So what's this all about? In theory, if you put something fairly big up into space now, like the final stage of a rocket booster, you are supposed to be able to bring it down in a controlled manner so that it will splash down harmlessly in the ocean, usually in the Pacific Ocean, because that's the biggest. The Chinese haven't really bothered with that. Now, I'll go back into the history of a few other things coming back down, but their Long March rocket, the final stage, goes right up into the orbit. A lot of other countries, when they're putting a satellite into orbit, the final stage takes it up almost into space. Then there's a small rocket motor on the payload itself, which takes it right up into its final orbit. The Long March 5B doesn't do that. The final stage, all 20 tons of it, goes right up into space, but then it comes down uncontrollably within a matter of, say, a week or two later. It has no way of controlling just how it comes down. And 20 tons of stuff coming down, if it was to land on a city, for example, would cause a lot of damage. And there's quite a bit of concern. Anyway, to come to the point, it did come down. Fortunately, as far as we can tell, no damage or injuries were recovered. It did pass over some land areas, as I mentioned, Malaysia and some other islands in the Philippines. So there may be other smaller parts that did land on landed areas rather than the sea, but the main part did come down in the sea. Now, the interesting thing about this is that NASA was giving off stink to China because they weren't doing this the so-called right way. In other words, having some little thrusters on the final stage so they could try and control its descent, conveniently forgetting that the very first big piece of stuff to crash down to Earth was actually Skylab, which landed in Western Australia in the 1970s. Was it 74? I think 79, sorry.
Yeah.
So they were guilty. And in fact, what happened was that they found the bits of the rocket in the desert, and NASA was actually fined for littering. It's a fine that they have yet to pay, by the way. I think the fine was $400 Australian. If that money is ever paid, I think they would probably keep the check and say another piece of memorabilia. But anyway, the whole question of big pieces of space junk coming back down to Earth is a worrying one. There's the problem of satellite impacts when it's up there, but the other big bits that come back down, unless they are controlled, sooner or later, somebody will get hit by one of them and there'll be damage. I mean, there have been other impacts. Just Skylab, I think, was the first. There was an impact in China, or sorry, in Canada, and another one in West Africa. But the Chinese don't seem to be bothering about this. But just interestingly, at the same time as this story was catching all the news, they found a piece of a SpaceX Falcon 9 rocket had actually landed on land in Australia. And everybody was keeping, well, particularly SpaceX, were keeping quite quiet about that. So a piece about the size of a sort of a telephone box, an old-fashioned telephone box, if you can still find them around the country anywhere, landed in the pasture of some Australian sheep farmers in the foothills of the Snowy Mountains in New South Wales. They quite unexpectedly found this thing, rang into a local radio station, and they were put through to an expert. When he saw photographs of it, he said, right, that certainly isn't anything normal or conventional. He went out and identified it. They're reasonably sure that it is a Falcon 9, or part of a Falcon 9, composite material, and it shows evidence of having been scorched in re-entry. So just to give you the details, it re-entered on the 9th of July, although it's only been discovered relatively recently. That's 20 months after it was launched. So SpaceX are just as guilty as the Chinese were. They put up this final bit of space material, and they were not controlling how it came back down to Earth. So SpaceX have been asked for a comment, and apparently nothing has been received yet. Yeah, you're right, 1979. So there's a whole big issue now, not only of the risk of debris collisions in space and giving us the Kessler syndrome, but if you do put up a big lump of material into space, which is going to come back down to Earth, hopefully without hitting anything in space on the way, you do need to be able to control where it lands and hopefully get it down safely in one of the uninhabited parts of the oceans. So it was just very interesting that NASA was busily criticizing China for what it wasn't doing, and at the same time, SpaceX had just committed the same sin, and it might never have been known about until these two farmers discovered the piece of debris in their pasture. So I'm sure you have views on that too.
There's lots on this. The first thing is, are the farmers putting it to Sotheby's for auction?
I hope so.
That'd be really good. It's interesting, though. SpaceX are far more culpable for all of the debris mess than anyone else. So NASA, ESA, whoever criticizing the Chinese is ridiculous. China, yes, they've had a few incidents. They had a launch that went awry about a year or so ago, where basically part of the first stage crashed into a house. You can't blame China. China are doing an awful lot scientifically at the moment in terms of space exploration. Fantastic successes on the lunar surface, fantastic successes on the Martian surface, whereas all SpaceX are doing right now, apart from obviously the development of Starship, and let's not beat about the bush here. Starship, yes, the aspiration is to take things to Mars, but that's going to be able to launch thousands and thousands of Starlinks, which is what Elon Musk needs. The FCC filings we've now seen, it's approaching 400,000 satellites in orbit. At the moment, there are over 4,500 active satellites orbiting the Earth in between LEO, MEO, and GEO. Nearly half of those now are SpaceX. They are by far and away the largest polluter and or operator in low Earth orbit. We've also got the increased activity from the sun right now. So, high X-class flares, high solar storms, etc., are taking satellites out. We've already seen this. A few months ago, SpaceX did a launch where the launch orbital insertion wasn't nominal. They got it wrong. There was a higher level of solar activity. Some of the satellites basically came out of orbit pretty quickly. Again, if you've got uncontrolled orbits, and don't forget Starlink itself, you're looking at something about the size of a refrigerator. They're not small. Those things are not going to completely disintegrate on re-entry. They are, potentially pieces could land. Something the size of a telephone box is going to land. Yeah. Something the size of a fridge, depending on what it's made of, obviously, is potentially going to land as well. You don't want that. You don't want large pieces. What this looks like is possibly an upper stage or a fairing. You look at the, SpaceX are now trying to recover as much of the spacecraft as possible. They've perfected the landing in the first stage. They're now trying to perfect, obviously, the recovery of the fairing stage, which is the bit that kind of encapsulates the spacecraft that's being put into orbit, the top, that bit that separates and then kind of drops back down. And they are aiming to kind of capture as much as possible. You've got companies like Lockheed Martin who are looking at helicopter recoveries as well, with pieces coming back in. But again, unless you've got absolute control and defined trajectories, all your range safety has been done properly, etc., you're going to get incidents like this. And as you said, Terry, at some point something's going to be hit. It'll either be a house or a person. And you look at meteorites. We'll go on to meteorites in a bit, but meteorites, we've had however many hundreds of thousands or millions of years of human existence. And so far, there's been a lady that got bruised in America in the 1950s, and a dog was killed in Egypt in 1919 in Nakla. We haven't had this yet. And that's kind of the argument. It's like the Titanic argument. It can't sink, and then it hits an iceberg. It's the same thing that's happening up in space right now in terms of both LEO and, as you said, with the Kessler syndrome. People saying, if space is big and we can put more junk up there. Well, eventually something's going to go very, very wrong, and that could be an uncontrolled deorbit crashing into a populated area. And a 20-ton piece is going to cause a lot of damage. It's not going to be a massive crater and explosion like you get with a huge meteorite impact, but it's not good no matter what. And as you said, the fact that SpaceX were almost hiding this and brushing it under the carpet, as it were, and then NASA are really heavily publicly criticizing the Chinese for what they were doing, just smacks a little bit of it's wrong.
It's not just the risk of being hit. Some of these bits that come back down are stuff that you wouldn't want to touch. They're contaminated by some very nasty chemicals. So you can imagine coming down somewhere near a village in Africa, say, and the local kids coming up and looking at it, no, look what I find, and suddenly
big hydrazine propellant tank,
nasty chemical burns and so on, things like that. So it is a serious issue.
Well, also you look at what the military are doing now, and the Ministry of Defense and the US Department of Defense are looking more and more, especially the US DoD, more and more into nuclear propulsion systems. We've got ion propulsion engines, etc., and a combination of nuclear ion propulsion, nuclear chemical propulsion. If you've got RTGs, you only have to go back. We're talking about the Apollo era before. The only thing that survived from Apollo 13, apart from the command module, obviously, which splashed down eventually safely in the ocean, and the parachutes attached to that and all the bits that they put inside it. The only bit of that entire mission to survive was the RTG, was the radioisotope thermonuclear generator, which is now sitting 30,000 feet below the Pacific in the Tonga Trench. That thing was designed not to break up. That's the whole point of the RTGs, are designed to be really resilient in case there's an accident during launch. You only have to look at nuclear waste being transported in trains. It's almost like you're building a tank around it to protect it. So this is the thing. If we've got in the future more and more nuclear powered spacecraft in low Earth orbit, and the reason they're talking about this is they want to be able to move the orbits, and the reason they want to be able to move the orbits is to avoid the debris mess that's going to happen. And anyway, it's all very, very, people just need to step back. And I had a chat with a group of advocates for kind of sustainability in space, and the UK government, talking about sustainability in space. They've just signed a massive contract with Eutelsat to, up OneWeb even more. And it's, in one breath, they're doing fantastic work with Earth observation and looking at, some of the great work, the scientific work that's been done in the EO spectrum from the UK in particular. But then on the other hand, they're backing OneWeb. And, we're going to compete against SpaceX. We're going to put up a gigantic cluster of 600, 700 satellites into low Earth orbit. We don't need that. It's like the Klondike all over again. And the rain of mess that could come down on us, compared to not even being able to get off the Earth, being almost imprisoned on this planet because you can't launch anything off it. It's all horrible. Robert's saying, do we see nuclear becoming a thing strictly illegal? Yeah, well, it's not illegal to launch nuclear into space. If you look at the Cassini spacecraft, you look at any of the deep space missions going back to Voyager, they were all nuclear powered. If you go much beyond Mars orbit, and Juno's been, one of the exceptions to this at Jupiter, where it's got vast solar arrays. But if you go really out into deep space, the missions that are planning for Uranus, for example, they're going to have to be nuclear powered. You just cannot derive the amounts of energy required for the orbital maneuvers, the spacecraft cameras, instrumentation, etc., just from solar panels alone when you're at that kind of distance. New Horizons is another example of a nuclear-powered spacecraft, and it's becoming more and more of a thing. And as I said, from the military perspective, they're looking at it as a way to quickly move things in orbit. Because with a nuclear propulsion system, you only have to look at the Mars rovers, which we're going to be going on to in a minute. The longevity of Spirit and Opportunity was largely determined by, yes, you had really good solar panels that could pick up a lot of sunlight even on the surface of Mars, but then with the dust storms and the increased amounts of debris and dust that was accumulating on the solar arrays on the side of Spirit and Opportunity, they basically was going to shut down anyway. And Ingenuity, the helicopter, obviously they're able to rotate the rotors, which have got the solar panels attached, to kind of spin the dust off. But if you've got a Martian winter and you've got a propensity for planet-wide dust storms, you've got to be looking at nuclear power on the Martian surface. And when we go back to the moon, it's going to be the same thing. Yes, you can derive a lot of sunlight if you're on the right side of the moon, but if you're deep inside a crater that sees no sunlight, how are you going to get power? This is the thing.
Yeah, just to clarify for anybody that's not quite sure, we're not talking about launching a nuclear rocket off the surface of the Earth.
No.
We're talking about powering the satellite for the final maneuvers as it gets to its destination, and keeping a power source there for the imaging and providing Earth. It's not basically a nuclear-powered rocket from Cape Canaveral.
Yeah, we had that, and I've got a book somewhere around here. Chap called Freeman Dyson, famous British physicist, who was really heavily involved in this. So if you think of Orion, now everyone thinks of Orion as the Lockheed kind of top part module of the Space Launch System and the Artemis missions. Orion was 60, 70 years ago, was a nuclear powered rocket that was basically going to drop small atomic bombs out the back and blast itself into orbit, and then blast itself, accelerating up to potentially 1/10 light speed. This was theoretically possible by basically pumping out small nuclear bombs out the back of the spacecraft, and you had a gigantic reinforced shock plate that essentially the explosion would continually accelerate the spacecraft. If you've not seen the book, I think it's called Project Orion. Freeman Dyson, if you just Google that, it's really, really fascinating, very interesting part of history that you'd never get away with in a million years now. But you look at Cassini. When Cassini launched, this is going back 20, 30 odd years, there were protests at Cape Canaveral when it was being launched, because people were saying, well, why, nukes, no nukes in space? It's like, we're not talking about weapons here. That will probably happen given Russia's current propensity for ignoring everything to do with, international human rights, etc. And that goes back to what we were saying at the beginning. We've now got the biggest piece of space debris apparently potentially coming our way, because the International Space Station, Russia, initially were threatening to pull out by 2024. Now, given that the guidance and navigation and the propulsion systems on the ISS are Russian or Russian-owned, the NASA can obviously do a lot with this. And NASA currently are so heavily reliant on SpaceX for everything. Yes, you could put a SpaceX craft up that could do boost maneuvers, so you can boost it into a higher orbit, but the navigation and guidance systems, a lot of the ISS is heavily reliant on Russian technology and Russian infrastructure. And if Russia were to pull out, and this threat apparently backfired, so Rogozin, the crazy lunatic who was in charge of Roscosmos, he's been fired. Even Putin fired him because he was just getting completely out of hand. Unfortunately, he's put in, I think, the Deputy Minister of Defense now in charge of Roscosmos, who's not much better. And he was threatening to pull out. They've retracted that now and said, oh, it's not what we really meant. But essentially, the ISS has only got a finite lifespan anyway. Then you are looking at something the size of a football pitch coming down. Now, if that were to come down in an uncontrolled manner, you would be talking about absolute havoc. You talked about Skylab before. Skylab was remnant parts of a Saturn V. Essentially, that was a really large spacecraft. Some of the videos you've seen, like Alan Bean, for example, running around the inside of it. It was fantastic, huge thing, using the S4B stage of a Saturn, or the second stage of a Saturn V. Amazingly huge, fantastic, scientific marvel it was in the early 1970s when it was launched, basically using remnant parts from the Apollo spacecraft. The ISS is so much bigger, so we could be looking at a real catastrophe here. Let's just hope the Russians eventually either back down, lose the war, whatever happens. But it'd be great to get science back on a sure footing. And as I said, America attacking the Chinese here is doing nobody any favors. It really isn't. The last thing we need now is a further geopolitical war. The tensions are already up in Taiwan, etc. don't antagonize this anymore. China have done some fantastic stuff, and obviously there's issues with human rights and all sorts of things. I'm not trying to defend China for their record in all of those domains, but from a space science perspective, they're doing some good stuff. So we shall see.
Right.
Leads us on to our final story, which is Mars. So the Mars sample return mission. This has had more changes than Kylie Minogue on a live set. It's incredible. They're basically, first of all, it was going to be the initial landing with Perseverance. That's picking up the samples, caching them in the storage. Perseverance. God, my mind's gone blank. Anyway, the rover. It is No, it isn't. Is it?
Perseverance and Ingenuity.
It is Percy. Yeah, it is Percy.
Percy.
Right. So yeah, I'm always getting my rovers mixed up. Anyway, they're caching the samples. Essentially, what was then going to happen was the European Space Agency were going to send Rosalind Franklin. That was going to be part of their rover mission. Then they were going to send what's called the Fetch rover. So the Fetch rover was basically going to land on the Mars surface with a separate Mars ascent vehicle. It was going to go and collect these samples and then bring it back to the Mars ascent vehicle, which was then going to launch a rocket into Mars orbit. And then that rocket was going to rendezvous with a Mars orbiting rocket, which was then going to come back to Earth and then crash land somewhere in the western United States desert. That's all changed again. Obviously, with what's happened with Russia and Ukraine, the ExoMars/Rosalind Franklin rover is no more. NASA and the European Space Agency are now talking to each other again, because NASA, don't forget, kind of left the European Space Agency in a bit of a lurch with regard to Rosalind Franklin, which is why the European Space Agency then turned to the Russians with the Proton launch system and the Kazakh lander. That's not happening anymore. Obviously, there's no collaboration whatsoever. It's complete ties cut now, apart from operations on the ISS between any of the Western space agencies and the Russians, as it were. So what we're now going to get is Percy itself is going to basically pick up its own samples. The longevity of the rover has now been proven to be much better than they anticipated. So what they're hoping is that once it's finished all of its sample caching and collection, then essentially it's going to be the primary redelivery vehicle to pick up the samples and take them back to the MAV, the Mars Ascent Vehicle. As a backup, on top of this, NASA are going to put 2 helicopters, so 2 Ingenuity scale and type helicopters, which if there's any problem with Perseverance in terms of picking up and recaching the samples and bringing them back to the MAV, they'll be able to pick up the samples, because they know the exact location of the samples. They'll be able to send the helos out, pick up the samples, bring them back to the MAV. The MAV has then got a European Space Agency designed robotic arm. The robotic arm will then load those onto the ascent vehicle, and this is where it gets really crazy, because then you've got our friends at Lockheed Martin yet again. I mean, they know what they're doing, but they're now designing the ascent vehicle. So this is going to be launched with what's called a vector launch. So not wanting to potentially break or disrupt the Martian surface, create dust clouds, disrupt the Mars ascent vehicle. If you imagine the ascent vehicle very similar to the Apollo concept, where you've got essentially the 2 parts will land, but then the bottom part becomes the launch pad, as it were, for the ascent stage. Essentially with this, they've got this kind of swing release mechanism that kind of catapults this ascent vehicle rocket, which has got 2 separate rockets on board, fires that up. That then launches, once it's clear of the Martian surface and the ascent vehicle, that then launches into Mars orbit. If you've seen the movie The Martian, it's pretty close to what we're talking about here. Then you've got this ascent vehicle, which then has to basically hone in on the Earth return orbiter, the ERO, which is the European Space Agency part designed craft again. That's then going to have to do a robotic arm transfer or cache transfer of the samples that are inside this vector launched ascent vehicle into the Earth return vehicle. That's then going to have to do a few orbits and then do an Earth return burn, come back on a home and transfer orbit. So 2033 transfer orbit, come back. Then it's going to go into Earth orbit from the return vehicle, which is enormous itself. It's got huge solar panels, huge solar arrays. That's then going to be basically eject the container capsule, which will have these Mars samples in, which will then crash through the Earth's atmosphere, decelerate, and hit the western United States desert sometime, we hope, in 2033. All of this, as you can imagine, is incredibly complex. And it's a multi-stage, multifaceted, multi-agency system, which is now being competed against with the Chinese. So the Chinese are saying, the European Space Agency, NASA, are saying that they can get the samples back by 2033. China are saying they're going to get theirs back by 2031. Now, given that China's record on Mars is 100% right now, they've got an orbiter, a rover, and a lander down first hit. They're not going to be probably as ambitious as NASA in terms of, you know, sending a rover out and exploring and digging little holes and caching samples. They'll probably be very content with where they land. They'll probably grab some samples, probably, you know, soil scoops, similar to the Viking landers. They may have a small rover, but similar to Viking, they'll cache the samples, they'll launch it from the launch site, from the landing site. They will then probably do the same thing. They'll orbit with a, you know, they'll rendezvous in orbit, in Mars orbit, and do a transfer back to Earth. So the race is on. On top of that, you've then got SpaceX threatening to send people to Mars before then on Starship. So who knows? It's really interesting, though, because it also leads into another quite interesting story related to one of the really famous Martian meteorites. And I'll just get a couple of examples here. I've got a few. I'll pull them up here. So one of the most famous Martian meteorites is basically this one. This one's called Black Beauty, NWA 7034. Now, the reason it's so famous is it's a beautiful meteorite in terms of its aesthetics and its color, but it's a Martian breccia. So this is basically the result of an earlier impact, and the initial dating on NWA 7034 and its parent, its partner meteorite NWA 7533, which is another example of one of these really old brecciated Martian meteorites. They've now redated it. So the initial dating that was done in 2013, they estimated around about 2.1 billion years ago. Now they're saying it's about 4.5 to 4.8 billion years old. So this is some of the oldest Martian material available on the surface of the Earth. And what they think happened was that around about 1.5 billion years ago, something hit the Martian surface, meteorite, that basically shocked the material in NWA 7034, created this brecciation, and then it kind of lay dormant until just a matter of a few 5 to 10 million years ago, they think, when another impact hit the surface of Mars and catapulted this material that had already been hit and shocked by an earlier Martian meteorite up into space with enough velocity to basically escape Mars's gravity and drift in, biggest gravitational force in the solar system being our sun, drift in and intersect the Earth. So basically these things crashed into Earth. NWA stands for Northwest Africa. They were both found in the Northwest African desert regions around about 2012 in the case of 7533. But the really interesting thing is that it's the age of these. They've now proven not only the age, but also using an artificial intelligence crater analysis tool where they've come from. And it's believed now that the initial impact was from, I believe it's called the Kjert crater. And then the secondary impact was from the Karaf crater. So they've used an AI engine, as it were, to analyze over 90 million separate craters on the surface of Mars based on all the orbital data that's come from the high-res cameras, from European Space Agency's ExoMars orbiters, etc. Collate all of that, look only at specific craters in terms of what the geology is saying around that crater region, but also what the age is saying around that crater region. And on that basis, they think now that they've identified where Black Beauty NWA 7034 came from. And it relates into this because we've now got a really good example of identifying where material has come from, much like we have with the Apollo missions. There's some evidence now that some of the lunar meteorites can be definitely cross-typed and cross-matched to the region around about the Apollo 16 landing site because of the sample returns that have come from Apollo. So when we do get actual sample returns from an actual known spot on the Martian surface, it's going to be really interesting to then go back to the 300 or so Martian meteorites that we've got and say, well, potentially we could type where these have come from. We could look at the actual craters where these meteorites came from. And to me, I found that really fascinating. I don't know, you picked up on this story, Terry. I don't know what your thoughts are.
Yeah, I just wonder what their confidence levels are that they've identified the actual crater. They can't be 100% sure.
No.
It's basically a best bet, a best match, but the crater that they came from could even have been destroyed by a subsequent later impact. Yeah. The other thing that's fascinating about that one, the Black Beauty, was that if it was formed originally, as you say, about 4.5 billion years ago, was it lying on the Martian surface for all that length of time?
Yes, that's what they believe, yeah.
well, or just possibly below the surface.
Yeah.
The difference being whether it was exposed to radiation from the sun and from cosmic rays for all that length of time. So presumably they can study it and say, yes, that was actually lying on the surface. And then you have the other question of dust blowing over it and blowing off it again and so on. But the whole question is absolutely fascinating. But as you've said many times before, and I agree, until you actually get boots on the ground on Mars and be able to do a detailed analysis of things like that, you can be maybe 99% certain, but you can't be absolutely sure. The other thing is that in terms of the Chinese method of returning samples, if they're using any sort of a descent engine to slow the impact, then there'll be a possibility of contaminating the material in the area where it touches down. So hopefully they will make the last 20, 30 feet or so of the descent under a parachute or under a free fall, then with impact absorbing legs or something like that. You certainly don't want engine exhaust blasting onto the surface and then picking up that surface material and saying that's your Martian sample.
Absolutely not. Yeah,
because it'd be totally contaminated.
Absolutely.
But yeah. I was thinking when I don't know this, obviously, all the detail of the complexity of the European plan to get samples back from Mars, you'd say that could never possibly work. Too many things to go wrong. And then you look at James Webb, which was just as complicated over a shorter time scale, but nevertheless, there were a similar number of absolutely mission critical mechanisms that had to all be done autonomously, and they did all work 100% perfectly.
It's slightly different though, in that with James Webb, it was one shot. They had to get it right. Everything had to go perfectly. They've already got, Perseverance on the Martian surface, picking up, collecting the samples. So if they were at some stage to land a MAV and say, right, we've got the MAV on the surface now, we've got the ascent vehicle, it's ready to go. If there was any problem with, Ingenuity coming back, you send another rover, you land another rover. There's ways to get this back. It's just it's the time scale. If this is now becoming a genuine space race yet again, between the US and the Chinese, for example, in terms of the first sample returns from the Martian surface. And obviously we're hoping that not long after that, 2033, don't forget, we're in the time frame when they were talking about getting people onto the surface of Mars, even from a scientific NASA perspective, not the the SpaceX Starship perspective. So, is it going to be the case that if this gets delayed any further, they're just going to say, look, what's the point? What's the point in doing an autonomous sample return when potentially we could be putting boots on the ground by the late 2030s? If you only got to wait 5 or 6 years to get, hundreds of kilograms of sample material. You only look at Apollo, it was hundreds of kilograms, and proper geologists on the Martian surface as well. It does weigh up those questions. If anyone wants to know what breccia is, by the way, that's a piece of impact breccia. Basically, what happens is that you've got an impact. Robert's asked the question, there must have been some collision. Yeah, heck of a collision. So you've got a massive collision that basically shatters the rock, and then you get an agglomeration of little bits of fragments cemented together to form this kind of brecciation. Some of the core drilled samples that are near the Chicxulub crater, if you've seen some of the documentaries that were put out a few years ago, some of the core sample drilling near where the impact crater for the one that killed the dinosaurs was, you can see this incredible shock wave, as it were, of like crushed, messed up rock. That's what breccia is. So if you didn't know what that was, just kind of thought I'd bring that one to light. But it's amazing. I mean, I'd love to get my hands on some actual Martian material rather than just Martian meteorites that, as you said, so your contamination, some of these things have been lying on the Earth's surface for tens of thousands of years, and you've got once you cut inside them, yes, you are looking at more pristine sample material. But I mean, with NWA 7034 with Black Beauty, it was one of the first meteorites, along with the Allen Hills ones, where they could definitely say water was on the Martian surface at some point. There's evidence that's percolate through it, showing evidence of water on Mars, and we know that now pretty much definitively that Mars was a lot wetter in the past.
Nick,
It's
we're
all-
almost out of time.
I know. Let's move on. Let's move on. We could go on forever.
Okay, I'll cut this quite a bit shorter. In terms of looking up at the sky, the main thing coming up in August is the Perseid meteor shower, one of the major showers of the year. An easy one to observe because you have nice warm August evenings. Maximum of the shower is on the evening of August the 12th. There are fragments of Comet 109P Swift-Tuttle, and they've given some amazing displays in the past. This year, the display itself will be just probably as good as usual. The problem is we have a full moon in the sky on the night of maximum. So that means the light from the moon will drown out all except the brighter meteors. But don't despair. The shower is actually active from the end of July right up until about the end of the third week in August. It's just that it reaches its maximum on the 12th, sometimes the 13th of August. So for the next 4 or 5 days or so, you'll still be seeing some Perseids and you'll have no moonlight to worry about because the moon is only just past new at the moment. Even up until about first quarter, if you wait for a while, it'll get so low that it won't be a problem. And after first quarter and up until the night of maximum, there are ways when you can still sort of minimize the effect. First thing is to position yourself somewhere in your back garden or somewhere else where the moon itself is behind the house or behind a tree or behind a wall or something like that, and then look in the other direction. You don't have to look at Perseus itself, the constellation where the meteors appear to come from, because the meteors can appear at any part of the sky. So in fact, if you look directly at the radiant, the point in Perseus, which is near the double cluster, you won't see as many meteors as you see if you look about 40, 50 degrees away from that. So look away from the moon, and even if it is a full moon, you'll still see the brighter meteors. And then the shower continues, although it tails off relatively rapidly after the 12th. So before, say, on the 14th, 15th of August, you'll still be seeing some Perseids, and you can look before the waning gibbous moon actually comes up. And finally, Saturn, the most beautiful planet in the sky, possibly the most beautiful planet in the galaxy, who knows? It's coming to opposition on the 14th of August, so it'll be quite close to the position where the moon is when the Perseids are at maximum. You need a telescope to see its beauty. If you haven't got one, go to your local astronomy club or something. Don't just look at pictures in a book or on your phone or on a TV screen or whatever. Go and see the photons coming through the eyepiece into your eyeball, and you'll go just wow. So very quickly, that's what to look up for in the next month or so.
Absolutely. And if you want to know what the meteors look like, I mean, you're looking at something, if you can see that, that's basically about the size or smaller of the average piece of meteor dust. We were also talking, and we'll probably allude to this in the next show, comet tails, which is 109P, as Terry said, is where we get the Perseids from. They can go on for hundreds of millions of kilometers, and you got all that dust flying around. Is that going to impact the James Webb? We don't know. We haven't worked out the orbital dynamics on that yet, but where it is at its Lagrange 2 point, around about a million and a half kilometers away from the Earth. It's all fascinating. It's all great to look up to. It's not the best time of year. Obviously, the summer, we've got very short nights, astronomical twilight, etc. Depending on where you are in even the UK, if you're in north of Scotland, it pretty much doesn't go properly dark anyway. But it's a great time, especially if you've got kids. Take them out, sit on a deck chair in your back garden, as Terry said. Try and avoid the moon if you can. Put it behind a tree or the house. Grab a flask of tea, flask of coffee, and just look up. It's fantastic. And on that note, I'll hand you back to our amazing host.
Yep.
Awesome. I mean, what can I say? Another great show. Thank you so much for bringing us the latest and greatest from across the universe. And thank you, Robert, for being so attuned within our show. Thank you for all of our quiet listeners too. Thanks for tuning in. Make sure you're subscribed to Space Door if you aren't already, and follow us on social media wherever you are. We are too. We'll be back in a month's time, the start of September, with another great show. Hopefully there's more amazing things in the news across the universe for the rest of August, and I'm sure Nick and Terry will be pleased to be back again in about a month's time. Thank you all for watching.
Don't be shy on YouTube. I know there's people watching this on YouTube because you've told me, so don't be shy. Come and join the chat. We love it. I mean, Robert, thank you. Massive thank you. We always love the questions that come in. So please don't ever be afraid to ask us questions.
And thanks to the back room, the new ones in the back room as well.
Yeah, nice one.
Yeah,
All right,
Cutter
guys,
nail
take
it.
care. Enjoy
Okay.
your summer.
Cheers,
Enjoy
guys,
your summer
everybody.
holidays, and
Bye.
we'll see you in
Bye.
September.
Bye.
Bye.